Hello everybody, my name is Bobby Lau, and today I'm going to be recording my Physics 2212 Lines of Charge, which is Lab 2. So for the introduction, the purpose was to use U-tape, which is charge tape, to compare the point charge model to the lines of charge model. Splitting tape into many point charges to more accurately portray charge of each tape. This is because the charge is distributed within the tape and not just at one singular point, which is what we did in the last experiment. Background. Tape is our representation of an electric field of distributed charge. Newton's second law, F equals ma, and Coulomb's law, F equals qe, is important to calculate charge on each piece of tape. And we are using superposition to find the value of the distributed charge, because essentially superposition is just the charge being split up along the entire tape. Results. My model found that the magnitude of electric force was that, magnitude of gravitational force was that, and that the final magnitude of charge on one piece of tape is 2.7858 e to the negative 8c. Air resistance is negligible, and each piece of tape has the same charge. The charge of each piece of tape is equally distributed, sorry. Those are the assumptions that make this possible. Set up for real world. The system is tape B, the surroundings is tape A and everything else, and the distance between them when we were experimenting was 0.05 meters or 5 centimeters. Onto the code. This is the results we got. And then for the constants, obviously 9 e to the 9 Phys, 9.8 in gravity. This is the mass of one tape in kilograms. This is the Q from my original lab over here from lab 1, 2212. Q is a arbitrary number that I made up to make this work. The length is, oh wait. Yeah, no, never mind. That's right. Yeah, okay, sorry. The length is 20 centimeters, just about. And the distance is about 2 centimeters apart. I divided that by 2 to make my calculations easier. My actual distance was 5 centimeters, so that's divisible by 2. And then these are the calculations that make all this that makes the code work. This is defining the E field, defining the line charge, and top tape and bottom tape. E scale, and then this is just what it spits out. For the original, this is from last week. Yabba dabba do. Anyway, so what does it mean in the grand scheme of it? What if I had modeled each of my tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental to produce a point charge model to the value you got in my line charge model. So, the original one I got in lab 1 was 2.3 e to the 8. And in this one, I got 2.7 e to the 8. And the second question is, why do these estimates differ? And which value is more likely to be closer to the real value, and why? So, the reason that I believe that this lab gave me a value closer to the actual value, or to the accurate real value, is the charge of the tape is not at one singular point, which is what is calculated in this one. Because this one is just like a simple computation model, assuming that it has one point of charge. In reality, the charge is definitely equally distributed among the tape, because we're ripping electrons from the entire thing, and that's what gives us its charge. We're not choosing one specific electron to rip out of the tape. That makes no sense. So this number, 2.785 e to the negative 8, would definitely be the value that is closer to the real world. Thank you very much for watching. It's been a pleasure. Have a great week.